Okay, factoring number 2. So let's look at these types of factoring. So this is going to be different than factoring number 1. As you can see, the two terms don't have a number you can factor out, and they don't have a variable that you can factor out either. Okay, so to factor something like this, you're going to start by writing down two sets of parentheses. And what you're going to do is, and this only works when you have a difference of two perfect squares. Now remember, a perfect square happens when you take something times itself and you get a number. Okay, 3 times 3 is 9, so 9 is a perfect square. Okay, it also works with variables. If I take x times x, I get a perfect square. So 9 and x squared is they are perfect squares. Okay, so when you have a subtraction problem, you can split it up like this. So x squared is going to split up to x times x. So these two would go in the first term spot in each group. And then 9 is going to break up to 3 and 3. Now, notice with this quadratic, there's no middle term. If you'll recall, a quadratic equation in standard form looks like this. Okay? But there's no middle term. There's just a first term and a constant. Okay, so to get rid of the middle term, one of these has to be plus and the other one has to be minus. Now, I'm not sure what you know about factoring or actually multiplying binomials, but if you've ever used FOIL, first, outer, inner, last, the inner is 3x. The outer would be negative 3x. And these together form your middle term, so they cancel each other out. Let's take a look at another example. Oh, and by the way, your first terms would be x times x, which is your x squared. 3 times negative 3 is negative 9. Okay, so let's take a look at this one. This is a perfect square. This is a perfect square. It's subtraction. So we're going to make our two parentheses, break up the y squared, break up the 25, and then one's plus and one's minus. And that would be your answer. The difference of two perfect squares. All right, let's go down to number 7 here. Here, 4 is a perfect square because 2 times 2. X squared is a perfect square. 81 is a perfect square because 9 times 9. And y squared is a perfect square because y times y. So we have a difference of perfect squares. These are all perfect squares. So we're going to make our two parentheses. So 4x squared is going to break down to 2x times 2x. 81y squared, 9y and 9y. One's plus, one's minus. All right, let's see. Are there any other types of problems here we could go over? Yeah, I can skip. I'll give you a bonus if there's any fraction problems on the assignment. You can give them a try, but I won't count off on them right now. Let's see. Yes. Let's take a look at this problem here. Notice it's not a difference. And they're not perfect squares. Well, one is, but x cubed is not a perfect square. But what we have here is we have a different type of problem. It's called the sum of two cubes. The sum of two cubes. And because a cube, this is a perfect cube, because x times x times x is x cubed. 1 is a perfect cube because 1 times 1 times 1 is 1. Well, there's a formula that you need to follow when factoring a sum of two cubes. And so this is going to be the formula. So our first term, I'm just going to use a. It's a formula. So something cubed plus something else cubed. So when you have something in this format where these two are perfect cubes, this is how you're going to factor it. I'm going to scroll out here. There we go. So what you're going to do is you're going to take the a plus the b, and the first factor is going to be a minus b. And then the second factor is you're going to take that a value and square it, plus a times b plus b squared. That's the formula. So let me show you how this works. The first thing we want to do is get the original equation in this format right here. So x cubed is already in that format. So x is going to represent a. Well, 1 isn't in that format, so we're going to change this to x cubed plus 1 cubed. Well, 1 cubed is 1. 1 times 1 times 1 is 1. So we know what a is, and we know what b is. So all we have to do is plug these two terms into this formula. So let me zoom out a little bit more so we can see this. There we go. So a is, first factor is going to be x minus b is 1. Okay, our next one, our a value is x, so plugging in x for a, x squared, plus a times b, so x times 1, which is 1x, plus b squared, so 1 squared is 1. And there is your answer. Now, another type is a difference of two cubes. That's where we'd have a cubed minus b cubed. Here we would have a plus b times a squared minus ab plus b squared. So let's look at an example of this. Let's see, 16 is 16 a perfect cube? 2 times 2 is 4, 4 times 2 is 8, nope, 3 times 3, nope, so that's not a difference of two cubes, because 16 is not a perfect cube. Is it a difference of two squares? No, that's not a perfect square. So this one is not factorable. All right, let's see. Hey, let's look at number 18 here. So 8 is a perfect cube because 2 times 2 times 2 is 8. 27 is a perfect cube because 3 times 3 times 3 is 27. Okay, so we're going to rewrite this as 2x cubed minus 3y cubed. Okay, this is going to be our a. This is going to be our b. Now, 2 cubed is 8. X cubed is x cubed. 3 cubed is 27. And y cubed is y cubed. Remember what I told you. You want to get it in the right format so that way we can plug it in to the factors for a and b. So it's going to be a plus b. So 2x plus 3y, and then a squared. So 2x squared minus a times b. So 2x times 3y, which is 6xy. And then finally plus b squared, so plus 3y squared. Now let's rewrite this. 2x plus 3y. 2x squared, 2 squared is 4. X squared is x squared. 3 squared is 9. Y squared is y squared. And there's your two factors. All right, so that's a lot to take in. Do your best and turn in your work. Thank you very much.